right? Because it's less than 1, right? That's what we learned before. It's decay, so it's going to go down like this, all right? Curve down, right? This one's 1/2 to the x power. This is 1/2 to the x power. The only thing that's different is this -4. All right, what's a -4 going to do? All right, to the right or down?
Down.
All right, how do you know?
It's outside.
All right, because it's outside, all right? On this one, if it's in the exponent, that would be right. If it's down here on the bottom, like on the same, not in the exponent, then it's down. Okay, that's one thing we're going to get used to. So this one is down 4 units. Okay, down 4 is what's happening there. All right, so I'm going to just do my graph. Doesn't have to be perfect. Okay, this one I am going to do numbers though. All right, let's see. I'll go 1, 2, 3, 4. 1, 2, 3, 4. It's been a little while since we talked about this, but one of the characteristics of exponential graphs is that they cross at 0, 1. Right, and the reason why is we talked about this last class. If the exponent is 0, what happens when an exponent is 0? What does it equal? 1, right? That's why it's 0, 1. Okay, all of them go through that because when x is 0, it's going to equal 1. Then another thing we talked about is if it's a growth, it's going to go through, the next number it's going to go through is 2. If it's a decay, the next number it's going to go through is 2 this way. Okay, so it's going to go through these 2 points, and that's enough for me to graph it. Just do your best. All right, curves. And then it gets as close to 0 as it can get without actually reaching 0. Right? And we didn't talk a ton about this, but the number that it gets as close to without touching is called an asymptote. Okay, that means the asymptote is 0 down here. That's why it's getting flatter and flatter and flatter and flatter. All right, and then we said this one is the same graph, but it just moved down 4. So I'm just going to take these points and move down 4. This is at 1, down 1, 2, 3, 4. All right, and take this one and move it down 1, 2, 3, 4. And do the same thing. Just finish my graph. I'm not going to graph all of them in here. Some we'll do in the calculator, but this one. This one, it went down 4, so instead of getting closer and closer to 0, it's getting closer and closer to -4 because of this -4. All right, you ready to move on? All right, okay. Number 2. Again, we're doing 8 problems. I don't know if I said that or not. Okay. Number 2, f of x equals e to the x power. G of x equals e to the x plus 3. All right, plus 2. Okay, and write it clearly so you can clearly see what's in the exponent and what's not. Okay, if you write sloppy, it's going to be confusing. All right, but I try to write really clear to help you guys and because it helps me. All right, we talked about the natural base e. That's also an exponential growth, right? It can be decay as well, but we only really did growth in class because I think those are more real life situations. But it's also exponential growth. So we had e here, e here. What are my 2 differences in my g? The exponent, right? It's got a plus 3. All right, and the plus 2. Those are my 2 transformations that we're looking at here. Okay, so now let's identify them. Okay, what is, if you have a plus 3 in the exponent, what is that doing? That's like being in parentheses on the ones we've done before. All right, It's left, right? It's left 3. In the exponent is left and right. This one is left. Plus is left, we've talked about. Left 3. And what about this plus 2? Right, up 2. Okay, left 3 and up 2. That's what those two transformations are. All right, and we're not going to draw the graph in class on this one, on our notes, but I want to show you how we can check it using the calculator. Okay, so go ahead and clear your RAM and go to y equals. And a lot of this, since there's exponents and like parentheses and stuff and using buttons that we're not super used to maybe, a lot of it will be getting used to where stuff goes, okay? So in f of x, we're going to put our original, which is second ln. That's how we get the e. The ln button is down by the 4. All right, so second ln. If you don't have a calculator, you can get one off an empty desk. All right, so e to the x power. And then this one, second ln x plus 3. And then I'm going to use the arrow key to go over, and it takes me down out of the exponent, plus 2. Right, and then you can look at the graph. Now, again, it's not always best.
Teachers, please release all students attending the Tempo Show. Please make sure to only release those students that have a ticket.
Okay, if you're attending the Tempo Show, first of all, you need to get out your ticket. Second of all, you need to put away all of your supplies. Third of all, you are responsible for watching the video and finishing this by next class. Okay? It's on you. You need to watch the video and do your online practice for next class. We're gonna have a little more time.
Where? Huh? You're not going? I'm not giving you the answers. I'm not giving you the answers. No.